teachers talking to you at what is basically a maths extravaganza. But we found in our experience, and I'm sure you have as well at some points, that there is a huge crossover between the world of computer science and the world of mathematics. On the board is one of my, I suppose you could call him one of my heroes, which makes sense with me being involved in the world of computing and teaching computer science. Steve Jobs, I'm sure you're no stranger to him. And this little saying that he came out with, I find particularly pertinent to our students. Creativity is all about connecting things, making connections between school, home, problems in the real world, mathematics, science, geography, in fact, any subject that the students encounter during their daily lives at school and in the greater community. It's all about teaching our young people to become problem solvers, effective problem solvers who can stand on their own 2 feet and represent themselves as resilient individuals, resilient learners, not only now while they're at school, but also beyond when they go to college, university and into the workplace. And that really lies as a fundamental part of what we do in our department and throughout the school at desk. We want to prepare our learners not just to be really fantastic in one particular subject or in a small range of skills. We want them to be creative developers across the board. It's our belief that technology, in particular digital technology and computing, can help them to do this. They learn transferable skills in our subject. And we also encourage other departments within the school to engage with what we do. And obviously, we get the students to make links as well with what they do in a computer science lesson, with what they might do in a mathematics lesson, a physics lesson, geography lesson. These are the key sort of skill areas that we look at imposing and then engaging with and then learning and becoming adept at through computer science. Design skills. If they have to create a solution to a problem, whether it be a new computer game, a program, web design, they have to have a set of creative skills. Logical thinking, those left brain type skills that are often associated with science and mathematics, they also play an important part. But as does the creative side, the right side of thinking as well. Calculations are a key component of programming. And you'll see from the slides and the things that I talked to you about later on in this presentation, the calculations really do play an important role in what we do. Decomposition, being presented with a problem, something quite challenging, perhaps a real world problem, being able to decompose it down into its component parts and provide almost mini solutions to each one of those parts. Real world problem solving is without doubt something that we base our whole curriculum around. As far as I'm concerned, you can't just make things up. The students have to be able to relate to a problem, whether it's a social problem, an issue that affects other people in the community that they see every day, or a global problem on a worldwide scale. If they recognise what these problems are and they can start to think about solutions to them and providing us with even a small solution through using some of these skills, we think that shows some success. Critical thinking obviously goes alongside the programming and the problem solving. And then innovation. If we're going to create a true 21st century workforce who can go out there into industry, stand firmly alongside other people, come up with solutions to problems, be effective, be professional, be entrepreneurs, then they have to start learning innovation at a young age. And I'm talking at primary school, not leaving it until secondary school. It has to be embedded in the curriculum right from the very beginnings. We have to teach them to be problem solvers and to be inventive. So how do we make it happen at desk? Okay. About 18 months ago, we went through a bit of a revolution in our department, and this coincided with changes in computer science, not just in this country, but mainly abroad in places like the UK and America. We had lots of famous people like Mark Zuckerberg, Bill Gates, making videos about the need for more people, young people, to be involved in computer science and programming. There was the Hour of Code initiative last year, and there'll be that again this year in December, where students can have the opportunity to engage with different ways of creatively solving problems and programming online, which is free of charge via their website. And it's all about empowering the students and giving them the opportunity to have a go at something which, for whatever reason, schools don't necessarily offer them. If you have a look at the PowerPoint slide I'm showing at the moment, there may be a few things on you that I think you might be thinking, oh, that's a little bit weird and a little bit wonderful. Minecraft, for instance. If any of you have got children, a lot of them these days think Minecraft is absolutely wonderful. I've got a 6-year-old who has it on an iPad, and I literally have to prise the iPad away from her every night. But it's not about the gamification of it. It's about getting them to use the games, but linking it to subject knowledge and skills that they have to learn as part of the curriculum. And for that reason, we've subscribed to a special version of Minecraft called Minecraft Edu, which has lots of modules built into it that allow the students to engage with other subjects, other types of knowledge within the Minecraft environment, so they can create their own virtual chemistry lab. They could create a sports auditorium that allows them to monitor performance. They can create weird and wonderful structures, needing to know dimensions, volumes. Lots of key skills that link to mathematics can be found in the world of Minecraft. It isn't just about building this virtual world in a computer game. There are a lot of problem-solving elements to Minecraft as well. We also try to innovate and get the students used to dealing with emerging technologies. And one thing we bought last year at Desk was a drone. Mr. Grogan has brought the drone along, and he's going to demonstrate that to you later. It's very much, well, I was a bit sceptical at first when I had my first experience with the drone. I thought it was one of those man gadgets, you know, that men like to play with, and it is to a certain degree. But once you actually start using it and you get to understand the technology that lies behind the drone, it's actually really quite exciting to use. While we found it exciting, the students found it even more exciting, because we could use it in lessons to teach them about other skills, other things they needed to know in other subjects like distance, speed, that sort of thing. Miss McGrogan will talk to you about that in a few minutes' time. Robots, we have several robots at Desk that specifically enable students to engage with programming languages, and I'll come to that a little bit later on as well. Ciphers and treasures. Students, especially the younger ones, love the idea of espionage, treasure hunting, anything that is mysterious, that can't be solved straight away. If you want to motivate them and get them really sucked into the world of coding, it's always good to lay this little treasure trail for them and really get them interested in it. 3D design and printing. We bought a MakerBot 3D printer about 3 months ago. And it is without doubt one of the most fantastic things we've ever purchased. The students are absolutely transfixed by it, as are some of the staff who come to watch it when we do our print runs. But the 3D printer really lends that reality to the idea of emerging technologies, to 3D design. The students can go on a computer, use a 3D design program, either at home or in school. They can come in and they can physically make something. They can bring it to life. And that's what we consider to be really important. They're not just talking about things. We want them to learn by doing. We want them to become creators. App creation, this year in Year 9 in particular, we've signed up for an initiative in the UK called Apps for Good. It's just been introduced to international schools. You pay a small fee and you have basically a part in a huge project where students work in teams in a competition to produce an app that solves a real-world problem. Notice again I'm referring back to these real-world problems. That's a prominent theme that runs throughout everything that we do. Programming, goes without saying, is something that is native to our department. Python in particular is a programming language that is becoming embedded into virtually every curriculum, I think, around the world at the moment. Moving on to what you do as maths teachers. I'm assuming that most of you are maths teachers. Our maths department at Desk has moved along in leaps and bounds, I'd say, in the last 12 months. Every teacher has their own Desk iPad. We've equipped every maths classroom. They've obviously got their existing smart boards, their HDMI projectors, but they've also got Apple TVs in there. We upskill them on a regular basis. You cannot expect teachers to start using evolving technologies without support. And that's what we as a department do. We're there not just for the students, but we're there for the other members of staff as well at Desk, who need support in how to adopt this technology in their particular subject. The maths department has also embraced gamification as well. They use the Desk student iPads to engage with My Maths websites and things like that, as I'm sure that you already know about and use. One thing that I'd like you to think about, if you are serious about embedding technology in your subject, is not just to think about your subject. Think beyond that. If you want to really motivate your students and get them working alongside with you, engaging with technology to support their learning in your subject, you need to look beyond it. Don't just rely on your curriculum. Think about how you can add it to it, how you can bring extra value to it. The people that we have in our care who we are supporting in terms of teaching and learning, they are digital natives. They've grown up with this technology. And to be honest with you, they expect you now to be able to use it as well. And that can sometimes be a little bit scary, I suppose. Co-creating your curriculum is basically involving your students and asking them what tools they want to use to learn and upskill themselves in your subject. How do they want you to support them? Yes. But almost as if, how can they support themselves? If you co-plan your curriculum and your schemes of work with some selected students, you'll be amazed how powerful it can be, because you can tie up your curriculum content with the way that they want to learn it. And then you'll really get them engaged. Okay, I'm going to hand over now to Ms. Pilgrim, who's going to talk to you about the links between mathematics and coding, or programming as we traditionally like to call it.
Good afternoon. So, as you can see, there's a great long list there of things that we cover in our curriculum at Key Stage 3. We particularly start with them in Year 9 on this kind of stuff. Year 9 are 14-year-olds, for those of you who aren't familiar with the UK curriculum. We do Python programming with them, and that involves them learning how to use variables, algorithms, and there is a close connection with maths in both of those. So algorithms, sorting and searching algorithms have a lot of calculations within them. Boolean logic, obviously that has a close connection also with mathematics. The calculations, you can actually use Python to create a calculator, so that would be something that would be a very good cross-curricular link with maths. Sequencing, order of construction, so there's the order that you have to write your language in. Fixing any errors, debugging your errors, and binary conversion, again, that is something that obviously is a maths-based concept. And we started to teach that to Year 9, so they're learning it actually in computer science on the UK curriculum before they learn it in maths, which is quite an interesting challenge as a non-trained maths teacher in that sense, trying to teach that to them. But they do get it, they grasp it, and they work together on it, and they succeed. And when they succeed with something that's very difficult, like the binary conversion, they get really excited about it. You'd be surprised, maths for me wasn't the most interesting subject when I was at school, but they really, really got to grips with this. It was a practical group task that they had to do, and they really got to grips with it, and they all understood the concept of binary conversion, binary to denary by the end of the lesson. So those are very, very valuable cross-curricular links between the two subjects. If you wanted to start something lower down school, so for example, the top end of primary or maybe year 7, so 11, 12-year-olds maybe, this is a really useful program. It's called Scratch. It was developed by MIT in the States. It's free to download, and it's a really good introduction to the concepts of programming. It's not really programming because you're provided with the blocks of code to insert in here. You can see the different coloured code blocks there. But what it does introduce them to is coordinates. So they have to move the character on the screen using coordinates. They have to use variables. They have to use calculations. They have to work out how to turn things. They have to know about angles, their distances. So there's lots and lots of maths embedded in that. And that is a really good way of introducing students to computer programming, coding, and at the same time you're introducing lots of really interesting maths concepts. You can make games and animations using Scratch. As I say, it's totally free to download. There are lots of really good resources on the Scratch website and examples of what other students and other people have created. And you can do some really amazing things with it. And we have used it very successfully with year 6 and year 7, which is 10, 11 sort of year-old students. Okay. Thank you.
As I mentioned earlier, one of the ways to get students really sort of excited about the world of programming is to get them thinking about how to be involved in espionage, being spies, and there's a whole world of stuff online relating to this particular topic. I remember my first interest in coding happened when I was probably about 10 years of age, and I watched a BBC documentary when I was living in the UK. And it was all about this mystery called Rennes-le-Château. And it was about this man in this small village in the south of France who was doing some renovations to a building, and he found inside part of a stone structure some papers with some code on it. He didn't know what the code was, he wasn't able to decipher it. But off he trotted to Paris to see someone very important in the church in Paris, and within a week or two he came back to the south of France to this small sleepy backwater village in the Pyrenean Mountains, and he was a multi-millionaire. And to this day nobody really knows what the secret was that he discovered. There have been lots of suggestions as to what it can be. Dan Brown's famous movie and book, The Da Vinci Code, is actually a straightforward rip-off of the Rennes-le-Château mystery. In fact, the authors and the producers of the first BBC documentary about it took him to court. They didn't win, but telling the students about real-life mysteries and trying to get them to solve the mystery themselves, even though other experts around the world haven't been able to do it, can actually be really stimulating for them, especially at the higher levels. There have just been some new coding mysteries issued to do with the Alan Turing film that's coming out starring Benedict Cumberbatch, which will be here in a few weeks' time at the film festival. And we're going to give that to some of our A-level students and ask them to see what they can do with it, alongside people at like Cambridge University and other institutions across the world. Why should we think that they are not able to do it just because of their age and the fact that they're in year 12 or 13? We're not going to put those restrictions on them, because invariably our students surprise us each and every day in what they can do and what they can achieve. And a lot of them know an awful lot more about coding now than we do. And they end up showing us things. And some students sort of, they've gone over and above what we would expect them to be able to do, and I think that's really fantastic. Because those students are therefore, they're being innovative, they're being creative, they're solving problems at a much higher level. This is a Year 9 class creating their own ciphers. So yes, we teach them about the Caesar cipher, and yes, we teach them about this one, which is the Atbash cipher, but then we want them to create their own ciphers. Interestingly enough, these two students are learning support students. They're on the LS register. One of them has dyslexia. I watched a TV documentary the other night about students with, I suppose, LS needs, particularly dyslexia. They actually make better coders, and they can decipher code quickly and more easily than people who don't have dyslexia. So I think that's a particular strength for them to play on. Okay, this is a typical maths solving problem that we might give to our Year 9 students. I want to convert kilograms into stone, etc., etc. What we want the students to do is think about how they would solve it in maths, first of all, and then translate that into programming code, and in particular, in Python. The general concepts between solving one of your equations or one of your problems is the same as it is for your students as it is for ours in computer science. They break the problem down into component parts and they solve each step. And at the end of it, they've written a program that fulfills all their needs and completes the solution. I mentioned earlier robots. I've spoken enough now, so I'm going to show you a few videos of the things that we do use at desk. So, if you like, it will bring it to life. And then I'm going to hand you over to Mr. McGrogan in a few moments, and he's going to show you our drone. So this is a robot that we bought initially last year from San Francisco from the supplier, but they now stock these in Virgin. Because obviously the video's running a little bit slowly on this equipment. Basically, the Romo is a little carriage. You put an iPhone in it, you download the app from the App Store, and away you go. The students program the robot as it then becomes, and it teaches them all about sequences, commands. It even has facial recognition software installed in it, so it can recognise the expressions on the students' faces. And if they smile, he smiles, and it can move around the table, it can track motion, that sort of thing. And it's a really good way to introduce, particularly the younger students, say in year 6 or 7, to the world of programming and algorithms. I think we're going to have problems with these videos, so I'm just going to talk to you about these, I think, instead. Tinkercad is a free online piece of software that allows your students to build 3D models. It's free of charge. It's absolutely fantastic. They can use it in school and at home. Set them a problem, get them to create something in 3D, get them to bring it into school, and away we go. Tangrams. Something as simple as that, get them to design some in 3D software, and then we get them to print it. Nursery and early primary, I don't know if there's anyone here who delivers lessons to younger students. I'll see if I can get this video to play. This is the precursor to Minecraft. Okay, you can see from that it's the same principle, but albeit at a lower learning level for Minecraft and block building. You can still engage the students and ask them to solve problems, although those problems will be of a much more simplistic nature. They can still build houses, structures. You can still set them little tasks to do with dimensions and distance and height and depth in something like that, and that's an iPad app. Minecraft, I've already spoken about. Amazing piece of software, the Minecraft Edu version. Slightly different from the standard gaming version, but it really does that the students absolutely love it. This is made in Minecraft by our Year 10 student here, and he's just going to tell you exactly what it is.
Hi, I'm Jan Matthew Carney, and I'm in Year 10 at Desk. As you probably have guessed, there's not much you can do with maths in Minecraft. You're not wrong. But at the same time, you're not correct, because there's a plugin, which is a separate program, which runs in conjunction with the server, that lets you spawn in a large chunk of blocks in any form. All you need is the dimensions. With this, alongside this, we scaled our blocks from the size they are in real life, and also used general feel of how the blocks look and aesthetics of the blocks to decide how big to make them.
Tell you what this is, first of all. This is a 3D representation of our school. So they've mapped out a whole school in Minecraft, and it's going to be used on school tours from the tablet, and people who visit desks, especially students from other schools or from visiting from abroad, they can walk around the campus and go in each block, and they'll know exactly where they are because they've got it in Minecraft.
And of course, with scaling, you need a ratio. So we racked our heads for 15 minutes deciding what to go with, and very simply in the end just decided to go with one Minecraft block is 1 cubic meter. Finally, we had to hollow out these big chunks of blocks, of course, to make the inside of the buildings of the school. And this took up some more time. But in the end, we decided to use the same command we used to place the blocks, to hollow them, and turn the insides back into air. But once again, we ran into another problem. What dimensions are we going to put in? So this one didn't take us as long, but we eventually decided to -1 of all the dimensions, and that would give us a hollow inside. And it worked. In the end, as you can see, it looks really nice. It is quite accurate if you're interested. You can see that it does look a lot like our actual campus. And yeah. And all of this is a great way to get students involved in a large project. With over 17 people owning the game on the computer alone, the possibilities for collaborating on such a large scale is there. With 3 people, this took us about a month and a half of working about 8 to 9 hours a week. Now, after all this hard work, we have found a way to give back to the school for giving us the time to do this and the permission to do this. We have turned it around into a Hunger Games themed event where students play for their house against each other, and eventually we plan to have a grand finale offering house points to the winner. Not only this, as Miss Finch mentioned, we are working on loading it onto a tablet and giving it to students so they can tour around the school and know exactly where they are and exactly what things look like and see the school from another perspective. Thank you.
I think that's a really good idea of what happens when you give students the means to do something, and you set them a problem, and they go away and they work as a team, they work collaboratively, and they solve that problem. And that's what it's all about for us. They used their creative skills, they were innovative, they used the software, they adapted it. And one thing that he kept saying as he was speaking was, we encountered a problem, but then we fixed it. And that's really the process that we want them to go through, and we want to train them to be able to do that for themselves. Which we have called Derek. Not quite sure where we got the name Derek from, but it seemed to fit quite well. So I'm going to hand you over to Mr. McGrogan now, who's going to show you how Derek works.
Bear with me 1 second, just while I set up. While that's running, I'll talk to you. Good afternoon. My name is Malcolm McGrogan. I'm now in my 3rd year in Dubai, working at Desk. And during that time, I've had some fantastic opportunities to teach and engage students through technology, both existing technology and emerging technology. Lisa's talked about some of it. We talk about the Romo, we talk about 3D printing. I'm going to talk a little bit about our drone, which is now connected. For those of you that don't know, you can see it in front of you. A drone is our drone. In particular, is a 4-propeller unmanned aerial vehicle. It's a quadcopter. And built into the base of it is a high-definition camera, which has a fisheye lens, gives it greater peripheral vision. And there are a number of uses for drones. Typically, the government use them for surveillance. We know that in Abu Dhabi, they're using it to monitor traffic and congestion throughout the city. And there is talk that there is potential use of using it as a postal service, a delivery service for ID cards, etc. But it's used beyond that. It's used to monitor nature. People use it to follow animals into areas where previously land vehicles were unable to reach, and this is a fantastic opportunity. The technology, as it's progressing, also balances out the cost of drones, and as such they're becoming more affordable for public, and they're becoming very, very popular, and that's one of the reasons we were able to get our drone. Now, we use our drone for slightly different purposes. We try to engage and teach students and embed it within our curriculum. I don't know what to try a video. I have a video of the sort of thing we do and the sort of thing that can be done with the drone. I'll try it for 1 minute. If it doesn't work, I'll just scoot on. So I'll explain what we're doing here. We knew the width of the football pitch, and what we challenged the students was to find out how fast the drone could travel. A very simple formula, very simple problem. But this was the challenge. I have cut the sound here because it was a very windy day and it started battering the microphone. So yeah, so this is them solving that problem they're talking about. They're talking about different ways that it could be solved. And you'll notice that our very own Ian Carney comes up with the answer.
Well, we knew the distance was 40 meters and the equation of speed equals distance over time. So we measured the time and we put both the values into the formula.
So how would you convert it?
You would
Divide it
multiply by
60.
1,000. No, multiply by 1,600 divided by 1,000.
No, it's 60 times 60 divided by 1,000.
Yeah, which is 3,000. Wait, what's the thing again? What's the thing again? The speed? 0.7.
3,600.
I'll try this guy's thing.
3,600
Get
divided
to
by...
kilometers per second.
Yes, 3,600, then you end up with
Yeah.
kilometers per second.
Okay, 45.828. That seems more reasonable.
Yeah. And what's that? Lawrence.
You told me to divide by this is the kilometers per hour. So basically, 45. Yeah.
Okay, so it's a short video. It's a short illustration of what we can do. And you can see that there's students from various year groups working together to try and solve that problem. I'm going to stop it before it plays again. And this is just one of our ways that we can engage our students in the classroom. The technology within the drone, however, allows more. It uses Wi-Fi. Instead of using infrared and radio waves, it uses Wi-Fi and has a Wi-Fi extender that allows up to 300 meters range. And we can use that to work out calculations of speed, as you've seen. It also uses GPS technology. And if it's set up properly, instead of the likes track the flight of the drone. It also allows a come home feature, so that if you lose connection between the controller and the drone, it will fly back to where it took off from and land safely. And it's super, and it's being able to give students something that 5 years ago they wouldn't have had access to, but would have seen in films, would have seen in movies, and gives them a hands-on experience of it. And that's what we try to do, as Lisa has said, and this is what I try to do with the drone in our lessons. Okay, and I've been asked to try and fly it. I'm going to try my very best not to take anybody's head off, but just to give you an example of how it can be controlled. Now, as I say, because the GPS isn't enabled, it will drift. Okay, what the GPS also will do outside is it will hold it in a stable position. Okay, so if I take off, you'll see that it will drift a little bit. As you can see there. Now, ideally outside, if you start to worry or start running into problems, you can let go of everything and it will stabilize, it will stay in one position. And I'm going to stop it there. But you can see just a little bit, you can see that it can maneuver it outside when it's using GPS. It is very, very stable. It's almost foolproof. So students can use it, teachers can use it. And yet they get a hands-on experience of this emerging technology that's become very much more popular in the public market. Thank you very much.
Right, everyone, thank you for your patience. That's the end of the presentation. If any of you've got any questions you'd like to ask, now is your opportunity. If any of you want to come and have a look at the drone a little bit more closely, you can do. Otherwise, thank you very much for your attention.